Factoring Review, Video 5. This will be the last video in this Factoring Review series. That does not mean that there are not more factoring techniques. There are two that I'm leaving out for the sake of time. Difference of cubes and sum of cubes. And there's also a technique called perfect square trinomials, which is just a special version of factoring trinomials. But for the sake of time, we'll just focus on difference of squares. And halfway through chapter 3, we'll learn a grand factoring technique that will work for any size problem. But like any universal technique, it takes more work. So this last technique is called difference of squares, and this is one that people just tend to remember, maybe because it's really easy. It's almost a formula. Difference of squares describes the way the problem looks before you factor it, a difference of two things that are squared. If you have a difference of two squares, then it factors into two binomials. You basically unsquare these pieces, stick a minus between them once, stick a plus between them the other time. Or visually, take apart these two A's and put them in the front of each parentheses, take apart the two B's and put them at the tail end, and then stick a minus and a plus. The hardest part about this is recognizing when to do it, and even that's not that hard. The difference part is easy, it's gotta be a minus. Oh, I guess while I'm at it, sum of squares, meaning if this were a plus, is prime. Well, 99% of the time, but for our purposes, if you see a sum of squares, you should assume it's prime. But all of these are difference of squares. Now, how do you spot a difference of squares? Well, first you look for a subtraction sign to indicate a difference. But then you look for things that are squares. Now, sometimes the squares are explicitly stated. This says x squared. Sometimes they are implied. This doesn't say a square, but 9 is 3 squared. Now, I'm going to show you a systematic way to take these apart every single time, but several of you are going to be able to look at this and instantly write the answer. The trick to factoring a difference of squares is to literally view it as something squared minus something squared. So unsquare each piece. What do you square to get x squared? Well, you square x to get x squared. Well, what do you square to get 9? 3. By unsquaring each piece, you are exposing the pieces that will go into each factor. So each factor for this first one will contain an x and a 3. So one factor is x minus 3, the other is x plus 3, and it's over. Again, this is almost what I call insta-factoring. The minute you say it's a difference of squares, it's practically over. I invite you to pause the video and see if you can factor the other two. Second one being 16a squared minus 9b squared. And the last one being x to the 4th minus 81. You might trip up on the last one a little bit, but even if you can see through it, you still might get tripped up if you're not paying attention. So I invite you to pause the video and try to factor both of these. But in the meanwhile, I'm going to move forward and factor both of them. Again, the trick to identifying a difference of squares is to make sure it's a difference, this is, and everything in it is a square. 16 and 9 are both squares. A squared and b squared are clearly both squares. As an intermediate step, you can literally rewrite it as something squared minus something squared and unsquare each piece. What do you square to get 16? 4. Wait, did you say 8? Stop that. 8 squared is not 16. 8 squared is 64. 4 squared is 16. What do you square to get a squared? A. What do you square to get 9? 3. And what do you square to get b squared? B. By writing it like this, you are literally exposing the terms and the factors. Now you may be able to see through it, and that's great. Meaning, you may be able to start here. The first term in each factor is 4a, that's what you square to get 16a squared. The second term in each factor is 3b, that's what you square to get 9b squared. One factor has a minus, one factor has a plus. And by the way, the reason they have to have opposite signs, if you FOIL this, the inner and outer products will cancel because they're the same numbers but opposite signs. That's why these are binomials and not trinomials. Let's try the last one. Now, if you're having trouble getting to the last one because this power is 4, I understand. But if you can write it as something squared minus something squared, we're good. 81, that's just 9 squared. Nothing to look at there. But what do you square to get x to the 4th? And the answer is, you square x squared. There's an exponent rule, previous previous knowledge that says if you raise a power to a power, you multiply. Well, if I'm going to view this as a square, I need to divide out the 2. So, in short, any power that's even can be written as a square. You just cut that power in half. So don't write this down, but had it said x to the 6th, then this would have been x to the 3rd, because 3 times 2 is 6. We're just trying to get the 2 out here. So let's put it back the way it was. And again, by rewriting it literally as a difference of 2 squares, you are exposing the pieces that will go in the factors. So one factor, the first term in each factor will be x squared, and the last term in each factor will be 9. One gets a minus, one gets a plus. Now, if you saw through it and got here, congratulations, good job. But if you had a homework question that simply said factor this, it would count this wrong. Not because it's incorrect, but because it's incomplete. So here's one of the things about factoring. It ain't over till it's over. In other words, if there's any factor that can factor further, you're expected to follow through. This is not only a difference of squares, it's the first problem that we did. So you would be expected to go, wait a minute, you can go into x minus 3 and x plus 3. What about this guy? He's a sum of squares, he's prime. If you don't believe it's prime, I challenge you to try to factor it. I don't care what you write, boil it out, it's not going to work. That being said, I'm going to drop a bonus question challenge to you. X squared plus 9 can be factored. You just can't factor it using real numbers. The first person who can show me what x squared plus 9 factors into with proof, don't just say here's the answer, you got to verify that it works. I'll give you 5 bonus points on your first test. The second person that does, I'll give 4 bonus points. The third person 3, second person 2, fourth person 2, and the fifth person, I'll just give them 1 bonus point. That's to discourage any sharing of answers. That's an internet class. I'm not sure if any of you will actually ever meet. But again, bonus question for bonus points on your first test. Sum of squares is prime. X squared plus 9 is prime, as long as you're restricted to real numbers. But if you go beyond that, it will factor. Give me an answer with a reason why it's the answer. Don't just say, here's the answer.